chapter we started on Tuesday, and then you guys did a practice on Wednesday, is logarithms. We talked about what a log is, why we need one, why we use one, and how, more importantly, how does it work, right? A log has the same parts as an exponent. They're just rearranged different. Still has a base, has an exponent, has an answer. They're just rearranged. Okay? All right, phones, put those away. Phones, turn them over, eyes up here. Here we go. Okay, so the difference with today, all of those rules still apply. These still apply. That's why I left it up here. The difference today is that we have a special type of log. It's called a natural log. Natural log. Okay? The difference between a regular log, like the ones we saw in the last set of notes that we did, these are regular logs, right? Natural log has a base of e. We talked about e a little bit last chapter. E is with the formula. We talked about e. E is a number. It's around 2.7, around there. Okay. So anytime you have a natural log, that just means a log with a base of e. That's all it means. Okay. It's kind of like when the log doesn't have a base, it's 10. Remember common log? We talked about that last time. This just has a base of e. So everything still applies. All the rules still apply. So the first thing you do anytime you see ln, change it to exactly this. They're exactly the same. Okay? Why is it? So it's called natural log, but it's ln. I don't know why it's ln and not nl. I really don't. I don't know why. Probably has something to do with Latin. The way you pronounce natural log starts with an L and N because most of the stuff was based off the Latin language. So I don't know. I honestly, I don't know why. But that's so ln means natural log. Okay. So the first thing you do, swap them. I don't want that. I want this. That's okay. Okay. So let's look at 1A. We saw questions like this yesterday. You saw questions like this. The only difference is it didn't say ln. It said log base of whatever, right? So the first thing you're going to do is you're going to change it, swap it out. Swap out this guy for a log with a base of e. Because it is a log. It just has a base of e. Okay? Now put the rest. E is the answer part. That e right there that I didn't highlight, that's the answer part. What we have to figure out is the exponent part, kind of like you guys did yesterday. Now it's a problem that you did yesterday. So how do I solve this? Change it to an exponent. Okay, you can use the loop trick. The loop trick said, start with the base, then go over here, then come back around. So we have e to the x power equals e. So I just swapped them around. Instead of a log, I put the base over here, e. Put the answer over here, also e. Put the exponent up here, x. Okay. So now, this guy has a power of x. What is power does this guy have? Yeah, if there is no power, it's always 1, right? So how do I make them equal? What do I need to make x equal to? What power I need to put here to make them the same? So the missing power is 1. The missing exponent is 1. If it had a 1, they'd be the same. Okay? Let's look at the next one. The next one has a natural log. So the first thing I'm going to do, before I even try to decide how to solve this, I'm going to rewrite it so that it has a log instead of a natural log. and it's missing an exponent part. Again. Okay. Get rid of the log. How do I do that? Loop trick. E to the x power equals the answer part, which is e to the 6th power. What is the missing power? 6. So the missing power has to be 6 for them to be equal. So it's exactly the same as you guys have been doing. The only difference is you have that natural log part. Well, change it. Change it to a log. Change it to a log with a base of e. All right, so now let's do this one. Again, first thing, I don't want ln, I want log with a base of e. This guy's a fraction. Missing that part. So to get that missing part over here, I have to do the loop. Okay. E to the x power equals 1 over e squared. So I know some of you guys in your head, you already know what the power is going to be. Some of you can do that. Go for it. Some of you are like, I still don't know. Well, this is how you found out. Okay, so my goal is to make both sides the same. I want them to look exactly the same, or as close to the same as they can. I see that this guy over here to the right, it's got a fraction. So how do I move this guy up so it doesn't have a fraction anymore? How do I get this guy, how do I move it up to the top floor? What are the rules for moving? When I move it up to the top floor, it has to have a negative power. Good. So when I move it up to the top floor, it doesn't need the fraction anymore because it's on the top floor now. What's the missing power? -2. Okay. Some of you can see it from here. Some of you can see it, oh, it's negative and it's squared. Go for it. That's fine. But I know some people, sometimes it's hard to see, so I just take that extra step if you need to. Okay. All right, a couple more of these type. Now we got a root. So this one, I'm going to change it. Everything else stays the same. So log with a base of e, and then it's the 3rd root of e squared. And I have to figure out what that is equal to. So I'm still finding the exponent part. Loop. E to the x power equals the 3rd root of e squared. Well, one of them doesn't have a root and the other does. How can I rewrite the root part so it doesn't have a root anymore? What power do I have to give it so it doesn't have a root anymore? A fraction power, right? Which fraction power would this guy get? 2/3, yeah, 2/3. Because it has a power of 2 and a root of 3. That's why we give it a fraction. If it has both, it gets a fraction. Now, what's the missing power? 2/3. Okay. Try the last one. Try the last one on your own. Try letter E on your own. See what you get. Give you a hint. This is the first step. Are there pencils over there? Yeah. Okay, so you change it to a log with a base of e. loop, e to the x power equals 1 over e. Got another fraction. Well, first of all, what power does the e on the bottom have? 1. So again, I need to move it up. It needs to move up. So to do that, I got to change it to a -1 power. So now to make them the same, they both need to have a power of -1. Done. That's the missing power. Okay. Okay, that's part of it. The other part is solving. Okay, we're going to solve now. Okay, so anytime you solve, anytime it says solve or find a solution, first thing to do is draw a line down the whatever symbol it is. In this case, they have an equal sign. So we're going to draw a line down there just to show one side versus the other. Okay, so the first thing, I want to solve, this is the part I want to solve for. I want to get x by itself. At the end, I want it to have x on one side, everything else on the other. Well, there's a problem. There's a bunch of stuff with it. Okay, first of all, they have a natural log. Well, we just learned anytime we see a natural log, change it to this. So that's the first thing I'm going to do. I'm going to change it. So I have a question. What is 4 doing with the natural log? Is it adding, subtracting, multiplying, or dividing them? It's multiplying, right? Anytime numbers and letters are stuck together in math, it's multiplication. So I'm going to put a little multiplication here. Log with a base of e, because these two guys are the same. Everything else stays the same. Okay. So I have to get x by itself. There's a lot of other stuff with it. So I can't get to the log first. So when we're solving, right, we know PEMDAS or GEMS, however your teacher taught you back in, elementary school or junior high. When we're solving, we always start at the bottom. We always start with addition and subtraction. Now, I have a -1 on the inside, and I have a -6 over here, right? I can't get to the inside yet because it's part of this log. So I'll leave that for later. So I'm going to start with this -6 over here. What's the opposite of -6? Adding 6. So I'm going to add 6 to both sides. Slowly, I want to take everything away, strip everything away. Oops, not that side, this side. So that all that's left is the log. So that leaves 4 times log base of e, 7x minus 1. Okay. The only addition and subtraction that's left is on the inside, but again, I can't get to that yet because that's part of the log. I'll deal with that later. So now I have multiplication. So what's the opposite of multiplication? Division. So we're going to divide both sides by 4. That makes a +1. So we have log with a base of e, 7x minus 1. 4 divided by 12 makes a 3. So now on this side, on the left side of the blue line, I only have the log. It's good. Okay. Now I want to get to this stuff that I've been ignoring, the 7x minus 1. I want to get to that. That's what I want to get to next. But in order for me to get in there, I have to get rid of the log. How do we get rid of a log? I'll give you a hint. We've been doing it for the last 2 days. And then we did it today too. How do I get rid of log? The loop trick, or change it from this guy to this guy. That's how you get rid of a log. Okay? So There we go. So it's going to be e to the third power equals 7x minus 1. Now 7x minus 1 no longer has the log part of it. So now it's free. Solve for x. How do I get x by itself? Got to go back to the bottom now. Add 1 to both sides. Last step, get x by itself, divide by 7, except I'm going to divide both each individually by 7 because they each get a divided by 7. So I get e to the third power divided by 7 plus 1/7. Since I can't reduce, I'm done. That's the answer they want. Now, if you were to put this into the calculator, you'd get an answer because E is not a letter. E is actually a number. So watch, I'll show you. And I'm showing you this for a reason, watch. Nope, I don't want that. What was it? Divided by 7 plus 1 divided by 7. So this answer is actually 3.01221956. They don't want that answer because that answer is a rounded answer. It keeps going, just the calculator stopped. So that's what we call a rounded answer. It wants the exact answer. The exact answer has no decimals. That guy does there. The other reason why they ask you for the exact answer instead of the rounded answer is because if I was to do this problem in photomath, mathways, any of those, and I was to say, solve this guy, take a picture of it, write it in there, guess what answer it would give you? It would give you this answer here. It's programmed to give you that answer there. That's not the answer I want. That's how I know. So that's an easy way to see if you're what I want this answer over here. That's the answer I want. Okay? Not that they're against photomath. Photomath has its purpose, but don't live off of it, right? Don't live off of it. If you're using it to I've tried this problem for 5-10 minutes and I can't get it, go for it. I don't mind if you use photomath for that purpose. Or I'm pretty sure I did this one right, but I want to check my answer. Go for it, right? But if you're living off of it, if every problem you're doing, you're just typing into photomath, that's a problem, okay? That's where it's going to be a problem, okay? All right, let's look at the next one. Same directions. I see a natural log. So the first thing I want to do is change that to a log with a base of e. So this stuff inside of the log is off limits right now. Can't touch it. I'll get to it later, but not yet. So the stuff that I can is the 3 times in the front and the plus 19. Well, if we're solving, we always start at the bottom of PEMDAS. So instead of adding 19, I'm going to do the opposite. Subtract 19. Divide by 3. Okay, now I can get to the log, but I don't want the log. To be able to get to 3x plus 9, I got to get rid of the log. So to get rid of the log, we use the loop. So we get e to the negative 2 power equals 3x plus 9. No more log. Once the log's gone, then I can actually solve it. So we subtract 9 from both sides. Divide by 3. Divide by 3. Divide by 3. E squared divided by 3. This guy I can actually divide. 3 and 9 I can reduce. I can divide them both by 3. It just becomes negative 3. Done. All right. Okay, so we got one more, and then I'm going to give you another practice to do. We'll do this one together. One more, do on your own, and we're done. This is a pretty short lesson. Okay? All right. Okay. Blue line. Rewrite log, or rewrite ln, I should say. Okay, can't get to 8x minus 3 because it's part of the log. So I'm going to start at the bottom, addition and subtraction. Divide by 6. Okay, now I need to get to 8x minus 3, so I got to do the loop trick to get rid of the log. For me to get to 8x minus 3, I can't have a log. Add 3 to both sides. Divide by 8. Divide by 8. Divide by 8. E I can't divide by 8. 3 and 8 can't be reduced, so leave them. E to the negative 3 divided by 8 plus 3, 8 over 3 equals 0. Mm-hmm.
Could you go up to the one?
The one right above it?
Yeah.
Uh-huh.
Do you know what happened to the e negative 2?
Oh, no, yeah, should still be there, yeah. Thank you. That should still be there, yeah.
Oh, thank God.
No, yeah. No, yeah. That was just a typo, yeah. Okay. That should still stay there. I didn't touch that.
I didn't know if there was like some rule.
No, yeah. I mean, you could, but you would have to move it down to the bottom, and I didn't do that. So, yeah, definitely needs negative power. Yeah, no, thank you. Make sure on letter B you have that. Okay? All right, so I'm going to pass some tape around. I want you to do one more problem, page 39, and we're done for today. Letter D. I want you to do this problem, then we're done. All right, so first thing, change ln so that has a natural log of e. After you do that, add 19 to both sides, divide by positive 2. Change from a log to an exponent, solve for x. E to the 8th divided by 7 plus 2 sevenths. Can't reduce any of the fractions. I'm done. All right, tape that in, and tomorrow we'll do some practice, and we're done for today.